Okay, so we're going to start to talk about factoring. First of all, we need to talk about this word factor right here. All right, we just took a quiz, which I will pass back to you at the end of the hour, on foiling, right? Foiling was when we multiplied two binomials, the first inside, outside, last, right? Well, if you take FOIL, so let's say x plus 3, x minus 5, and we FOILed that. So that was, remember, x squared minus 5x plus 3x, and then your positive 3 times your negative 5 gave you a product of negative 15. Then we combined our like terms, and we had an answer of x squared minus 2x minus 15, right? Okay? That's called foiling. Factoring undoes foiling. Factoring is where you start with the answer and ask yourself, what two binomials did I multiply to get that? So I don't know if you remember or not. Let's cover it up to see if you can kind of remember what we started with. So that would mean that they give you the answer, and you have to try to figure out what two binomials you got when you to multiply that. Okay, so factoring just means working backwards with the answer. So you know you have to add an x times an x, right? This is not what we're learning today. I'm just kind of trying to show you what factoring is. So this is a negative product, and the only way to get a negative product is to multiply a positive times a negative, right? And remember, the inside was a sum. Well, the only way to get negative 15 as a product is either to do negative 3 times positive 5 or positive 3 times negative 5, right? So for the product, it doesn't matter. It's for the sum that would matter. So which one of these would give me a sum of negative 2 if the 5 was negative? So that's how we're going to know that, okay? We're not there yet. We're going to get there after break. Let's start with something easier. Let's start with, say, 36 is my product instead of that trinomial. What are some ways to get 36? Think about that when you multiply them. First of all, I need you to know this, that a product comes from a factor times another factor, right? That's what a factor is. So give me some factors of 36. Let's do them organized. Go ahead. 6. But let's when I say organized, do you remember back to like 4th grade where your teacher asked you times what? 18. 3 times 4 times 5 times anything? No. 6 times 6. These are all factors, and when I'm done and I can kind of start going up back this way, I know I'm done. So I just factored 36. Okay? Meaning I was given the product and I told you what the factors were. That's all factoring is, okay? So if I were to say that's how you factor 36. Now, let's factor 24. 24, same way. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So 36 has 10 factors. 24 has 8 factors. Okay? Now, the title of this lesson is GCF, and that stands for what? Greatest common factor. So do you remember your 4th grade teacher saying, what factors do 36 and 24 have in common? You said 1. Every factor has 1 in common. 2, 3. They even have a 4 in common. They even have a 6 in common. But I'm not looking for just common factors. I'm looking for the greatest common factor, and that would be 12. So the GCF of 12 or of 36 and 24 is 12. Okay, so you remember that? Well, this isn't 4th grade anymore. It's high school algebra. So I want to know what the GCF of x to the 3rd and x to the 5th is. Okay, so this is where we apply knowledge that we've already learned to newer concepts in algebra. So the factors of x to the 3rd means I just multiplied x times x times x to get x to the 3rd, right? So what would the factors of x to 5th be? X times itself 5 times, right? So looking at what they have in common, they have what in common? How many do they have in common, I should say? 3. So they have 3 here and 3 here. So what do you think the GCF of x to the third and x to the fifth is? X to the third. Okay, there's going to be a shortcut for you to kind of think about that. So in other words, if they both had to give me the same amount of x's, what's the most that they could both give me? The most that they could both give me is the one that has the least, right? The lowest. Because, yeah, I can get 4 out of this one, but I can't get 4 out of here. Do you know what I mean? So if I were to ask you what's the GCF of a and a to the fourth, well, let's factor a to the fourth. A to the fourth is a times a times a times a. And a is just a. What's the most they can both give me? Just an a. So the GCF of a and a to the fourth is just a. What's the shorter cut for that? I don't have to write them out every time. It's always the exponent that's smallest. Okay? So the GCF is going to be your smallest exponent. Okay, and doesn't that make sense? That's the only way that you're going to get the same amount from both products there. So now let's put this together. So let's put the numbers together with the, I'll even use the same examples. Let's just say 36x to the third plus 24x to the fifth. Okay, so you're going to be given a binomial, trinomial today, and they're going to ask you to factor out the GCF. Okay, so the first thing to do is you got to find it. Well, you have to know the GCF of 36 and 24 was 12, and then you have to know the GCF of of x cubed and x to the fifth is x to the third. So now at this point, you have some options. I'm going to show you 2 ways. You're going to figure out which way you like better, because you're not done there. They want to know, they're not just asking you what's the GCF, they're asking you to factor it out. In other words, well, you could look at it as, hey, I'm just going to distribute it back in. If I multiplied 12x to the third times something and got 36x to the third, that must mean that I must have multiplied it by 3, right? Just 3. Why not any x's? Because I don't need any more, yeah, right? What if I put an x there? That would mean what? That would be x to the fourth, and it's not. So then, what did I multiply 12x to the third by to get 24x to the fifth? This is where your exponent rules come in awfully handy, right? 2x to the second. Because you know that your exponents have to add up to give you 5. So that is this answer. One way of looking at it is kind of like a fill-in-the-blank multiplication. Really, fill-in-the-blank multiplication is another way of doing division, isn't it? So essentially what you're doing is just dividing each of these terms by the GCF to get the other factor, right? That's how it works. So you're going to take 24x to the fifth, and none of this is stuff that you have to show. You don't have to show any of it. I'm just kind of showing you in your head the steps that you would arrive at. So 36 divided by 12 is 3, and remember those cancel, okay? 24 divided by 12 is 2, and those don't cancel. It's 5 minus 3, and that's where you get your answer there. Okay, is everybody good with that one? So let's try this one. 12x plus 42y. And obviously you're going to see that sometimes they don't have a variable that is in common. Right now, they both have a 1 in common, they both have a 2 in common, but what is the GCF, the greatest one? 6. I can pull an x out of here, but not out of here. I can pull a y out of here, but not out of here. So I can't pull any variables out. Just a 6. And so what would be left in the parentheses after I factor that 6 out? 2x plus 7y. And that is called factoring out the GCF. Okay? So how about you're going to see some, and part of this assignment is having you, let's say 4x to the fourth. Let's see second. Plus 24x cubed. You're going to see some like this in the book. And there's a whole separate part of that we're going to learn later. I want you to just kind of ignore that equals 0 for right now. You'll learn about what it means, but I still want to use the problems. Okay? So what would you factor out of 24x to the second? Or a 4x to the second in that? You could pull out a whole 4x squared, can't you? Right? Because you can pull a 4 here, 2 here. So what does that mean I have left? What would I need to multiply? What would need to go right here? This is tricky. A 1, right? Because you can't just put nothing. You can't put 0, because then it would be 0. And then what would go here? A 6 and an x. And do me a favor. For right now, that's all you're going to do in your answer. Is just copy it down, and we'll learn about that after break. Okay? Now, you're also going to see something like this. 6n squared equals 15n, which means you see the equal sign, but you don't see the 0. So I want you to get it to equal 0, which means everything with a variable has to be on the left-hand side over here for you to do that. So what would you do to get that equal to 0? Just subtract it from both sides, right? So that's going to give you 6n squared minus 15n equals 0. And now what can you factor out of 6n squared and 15n? A 3 and an n. Because I have 1 here. It's always the smallest exponent, and that's a 1. So this is going to give me 3n. And what's left here? 2n minus 5. Put your equal 0. You'll know why later. And that's your answer. Okay? Everybody understand factoring out the GCF. So it's one thing to be able to find the GCF. It's another thing to be able to put what's left in the parentheses after you factor that out. Yes. Okay? Just for the ones that have the equal sign in it. There's going to be 2 sections in your homework when you do it. So the ones that have the equal 0, just put the equal 0 there. Okay?